Now it is time to create the cluster. So let me go to the cluster. I'm going to create a cluster here. Again, I'm not going with Fargate. I'm going to use the EC2 Linux plus networking as the option for the cluster. Next, I give a name. So this is a demo. So I will give a demo cluster as the name of the cluster. I will go with the on-demand instance, and obviously I will select the T2 micro. I'm going to have how many? Maybe maximum four instances. Four instances not actually required, but then let us create four instances. I will go with the AMI whatever is proposed by the Amazon, 30 GB of hard disk. I have already created some key pair, and I will be using that particular key pair if I need to SSH into any of these, which I'm not going to, but in case. And then which is the VPC in which this cluster is going to be created? Obviously, our custom VPC. And then I will select all the subnets, the private subnet as well as the public subnet in this case, and then we'll use the assign public for the public subnet. So in this case, what we would like to know that when I created this particular VPC, which so if you look at the particular VPC, this custom VPC, I made sure that this DNS host names is enabled as well as the DNS resolution is enabled. So what I just did, I just edited the so you can see edit DNS host names. So make sure that it is in the enabled as well as in the DNS resolution also. Please make sure it is enabled. That is step one. And also for the subnets, for the public subnets that I have created in the public subnets, I'm making sure that the IP address. So you can see here, enable auto assign public IP address. This is also being checked for the public subnets. So because I'm giving auto assign public IP addresses, each EC2 instance that I am going to put into these public subnets will get a public IP address. That's all there is to it. So when I'm creating the ECS, use the subnet settings means, of course, the private uh, subnets won't get public IP addresses. Only the public subnets will get the public IPs. So that's one thing. And then there is the security group. So again, one more thing. Let us create one more security group, this time for the ECS cluster. So I'm going to create. So I will give ECS SG, meaning I'm going to create a security group for the ECS clusters. So what exactly this means? When we are creating the ECS cluster, we told you four instances will be created. So those EC2 instances, of course, a security group has to associate it with those EC2 instances. So this particular security group is going to be associated with those instances created by the cluster. So again, the security group has to be associated with our VPC. And then what are the inbound rules? Of course, if you want to SSH to those public, you can definitely use SSH. And then another rule. So I'm going to create a custom rule. So in this case, if you remember when we created these tasks, uh, if you go back, uh, yeah, I cannot show this now. If you remember, if you look at the previous video, when we created the task, we specified dynamic port mapping. So what we are going to tell, any port from 32767 from 65535, because the ports, the dynamic ports will be in this particular range. So what I'm telling here is that any communication that is going to come to this particular, from where? From custom means I want to have the two security groups. So if you remember, we had two security groups, one for the external load balancer, and then another custom rule again for the same thing from the internal load balancer to not load balancer from the security group of that particular load balancer. So what we are telling here is that please allow traffic to the EC2 instance. Again, the security group which we are going to be associated with this particular cluster. What exactly this cluster means? 4 EC2 instances will be created, and those EC2 instances should have a security group associated with it. So that security group is what we are actually configuring now. And we are telling that that security group should allow these port, any communication coming to these ports coming from the security group that is associated with the external load balancer as well as from the internal load balancer should be allowed to pass through. These are the two rules. Of course, SSH is not required if you don't want to SSH from there, but these two configurations are a must. So let us create the security group. So we have created one more security group here with the name ECS SG. As always, let us copy paste the name here too so that it is easy to find it out. So you can see here, again reiterating, we have created two rules, inbound rules. One will allow traffic to any of these ports from the internal load balancer security group as well as from the external load balancer security group. Okay, when I say external load balancer security group, this is associated with the external load balancer, and one will be associated with the internal load balancer. So whatever traffic coming from those load balancers to which these security groups are associated, please allow traffic from there to come in. And of course, these ports are opened up. And then because we are creating, so here let us use that particular VPC instead of creating a new security group. I'm going to use the ECS SG that we have created just now. That's all for the creation of the cluster. So again, I gave a name to the cluster. I have specified on-demand instances of T2 micro, 4 instances, 4 EC2 instances, and I'm giving a key pair if you want to log into any public EC2 instances. All the 4 subnets I have specified, both private and public, and then I'm specifying please assign IP address wherever applicable. If it is a public subnet, IP address will be available. If it is a private, it won't be assigning any public IP addresses. And then I specified the security group that will allow traffic from the security groups of the public as well as the private load balancers. That's all. Let us go ahead and create it. Of course, it may take some time for the whole provisioning to work. So let us wait. So now the cluster has been created. Let us go ahead and view the cluster. If you look at the ECS instances, of course, it will take some time. If you go and look at the instances that we have created, you can see these are the 4 instances that has been started by the ECS cluster. It may take some time to get the whole thing running. So let us wait for the whole thing running. So now that the EC2 instances are running, let us go back to the ECS and see whether these instances are appearing. So again, this may take some time. So let us wait. So as of now, 2 instances are appearing here. We need 2 more instances to be appearing here. So of course, the status check has to be passed for the ECS instances to be appearing here. And now, of course, we can see these instances are now up and running. But before we actually create the service, there is one more thing that we should do. So our use case is like this. We want both the config server as well as the booking service to be provisioned in private subnets. only the API gateway. If you remember, we created the load balancers, load balancers. So this load balancer will look for instances in the private subnets. So because we don't want the config server to be exposed to the outside world, as well as the book service doesn't need to be exposed to the outside world. We only want the API gateway to be exposed to the outside world. So when we create a task, we need to tell I mean, when we create the services, we need to tell to which instances or into which subnets these services or the task should be deployed. For that, what we are going to do, I will click and so first I have to check whether which is public or private. So I will go with the first one and see. So you can see there is a private IP. So I think uh, let me look at the ECS instance. Let me close this ECR. It is not required anymore. Um, if you look at the ECS instance, I want to see whether this is private or public. So this is a private subnet. So what I'm going to do here, I'm going to click on that particular instance, go to actions, and click on the view edit attributes. So you can see a lot of attributes has been added to this particular instance. I'm going to add a particular attribute here, and I'm going to give, this is custom attributes. You can give group, and then I will give the name as private or the value as private here. I will click on the green button and apply that attribute to that particular one instance and close it. So I have done with that. The second, again, I will look at the this instance and see which is this is public. So I will go here, go to action, edit the tag, and I will add an attribute, the same name, group, and I will give the value as public. Again, the usage of this thing will be obvious. That means we want to allocate these tasks based on these attributes. If the API gateway, once we want the API gateway deployed to a particular instance that has this custom attribute of group with the value of public, all the other things, that means the private means we want to allocate those instances. So let me see if this is public. So this is public. So the third one, let me go to the actions, edit it, and then add an attribute of group as public, and then check it and close. And the last instance, I hope this is private. So the last instance, we are going to select edit and then add the attribute group as private, and then save it and close it. So what we have done here, we have just given some attributes to these based on whether it is located in the private or public subnets. So you can see here, the first is located in the private subnet. The second one is in the public subnet. The third one is in again public, and then the fourth one, that means the EC2 instance, is in private. So we have effectively two instances that is running in the public subnets and two instances running in private subnets. Why exactly we are giving these tags will come obvious when we actually start creating the services. So we will start creating the services in the next video. So in this video, we created the cluster with the 4 T2 micro instances. Once those instances were provisioned, we went into those instances, found out whether this has been deployed in public or private subnets, and then we added an attribute to each of these instances, a custom attribute. Already, the ECS cluster has given some built-in attributes. And then, apart from this, we could use any of these attributes. But then, I am choosing a custom attribute. We are going to use this attribute. Again, you can edit it if you want. We will be using these attributes. When we provision the services, we are going to tell, please run a task that has this particular custom attribute. So effectively, the book service as well as the config service, we want to be deployed into a private subnet. I mean, the EC2 instances running on a private subnet. But the API gateway, we want that to be deployed into an EC2 instance running in a public subnet. For this, we have given this configuration. So that's the end of this video. We will create the service in the next one.